about privacy protection for video surveillance service. Actually, it is based on blockchain network and PKI public key infrastructure. And this study is part of research of security labs at SK Telecom. Oh, can you hear me? I can listen my voice again after a few seconds later.
No, it's okay. I can hear you.
Okay, thank you. Thank you, confirm. Okay, the background. My study is inspired by the thinking of nature of video surveillance service. This service has two. There are many concerns, but these two issues are mainly concerns. Person-wise, the system always recording unwanted and unaware the situation, and location-wise, the video surveillance service always records security zones and were reluctant to be public. Normally, the service is very secure, and they has responsibility of keep the recordings insecure. But the problem is TCB problem. No service provide concrete evidence how they can handle the recordings insecure. User and service where systems should trust the service provider. They keep their recording insecure. And another problem is the related to recordings. The recording files can be kept in secure in video surveillance service. But if someone copies the recordings and the recordings move to outside of service, user or the owner lost control factors about the recordings. So we start study to solve how we can trust the surveillance service and keep privacy protection with concrete evidence. These are related works, actually based research of this our study. First one is the standard for video encryption that provide video encryption per track and per times, even they provide the encryption method for time slice, timely sliced. And second one is DRM based on the blockchain that shows utilizing blockchain as DRM database. It is very good approach because video surveillance service usually record video as like a media file. So we need to check how to protect the media files, and we need to check decentralized approach is possible based on these approaches. Another one is PKI. PKI is very base concept to encrypt any data, but this third research provide a possibility to build PKI system based on the blockchain nature. And very interesting research comes medical science. On researchers try to protect electronic medical records with blockchain network. This research provides a method to protect data that is not generated by owner. Usually, hospital or the medical machines generate patient data, and they provide a method to keep patient data. But if patient doesn't allow to access the data, no hospital, no doctors can access the data. This is very important concept for our approach. And the last one is the blockchain, is about blockchain performance. They provide how big size of data can be handled in blockchain network, and they indicate which is the most significant factors when handling data on blockchain. So we made a this is our proposed architecture. There are several components with based on the blockchain network. The main concept is user and service can share their public key each other to check they shared to check if they shared public key correctly. Compound identity is introduced, but the problem of compound identity is the complexity. If service and users, the pair of service and users increased, the compound identity, the complexity of compound identity increase also. So we introduced the asset identity. The main different thing is that unidirectional way. User just possess assets. This is opposite. The assets usually get users public key. Then users don't need to have assets public key. So it reduces complexity. That is the key to handle lots of recordings and lots of services in this approach. So again, asset identity is a kind of relation of user and camera or user and encrypted video. That means the files, recording files. So to introduce this concept, we just focused on what user has. The asset just has user's public key, that's it. That makes a very simple architecture. And we introduced the nonce. Nonce means just a symmetric key, but encrypted by user's public key. The formula, the simple formula is like that. Usually to identify which user has the nonce, so public key of user and not encrypted symmetric key means nonce is a pair. The main points of the asset identity is that, as I mentioned before, nonce is not affected by number of cameras or files, so it reduces complexity. So to keep secure our video recordings in video surveillance service, there are basic protocols. First one is encrypted recording. That means that way is to keep secure video files. Everyone can copy or possess the encrypted video, but without permission of user, they can't play video files. That means that way is to keep video secure as a perspective of the point of users' privacy protection. And nonce is decryptable only when access blockchain network. So every operation to access nonce is logging. So user always can trace which user or which systems try to access nonce. And the final thing is that we are we are talking about secure video. So we need basic operations to create video and read and update and even delete. I think the deletion, remove the video, encrypted video file is very big contribution of this study, because we all not sure, we can't remove share the video from the internet, and we cannot sure. But if anyone can decrypt the video file, we regard it as removed. That's the big important concept of my study. So this is about create operation. We named it store secure data transactions. In this procedure, I introduced video file. MENC means encrypted media file, but it has asset information and nonce information as a metadata. It takes advantage of the structure of media file. So if anyone can access the metadata of encrypted media, and they can nonce and asset information, and then they can try to actual data from blockchain memory by the nonce or asset information, then with users public key, they can request actual data from the data stores.
Yeah, John, so Kim, please remember that you have limited time. You have like 6 more minutes.
Oh, okay. I'm sorry.
Sorry, it's okay. It's okay. Go ahead.
Okay, I will.
But we want to have time to ask you questions and everything.
Okay.
Speed up a little bit. Yes.
Okay. Quickly say. And second is load secure data transaction. This is about how to extract data from blockchain network and data stores. But it is a read operation, but I added 2 auxiliary functions. First one is check polish, is to check whether user possesses the asset. To run this functions, it should access blockchain network again. Another function is validate asset, is to check whether the given public key is valid to decrypt nonce. Surely, validate asset also needs to access blockchain network, so user cannot get notice from these 2 functions. These 2 functions is the main key of trace to provide a feature to traceable on blockchain network. And this is about the update operation. We just think about moving ownership from user to the other users. If none of the other users is added to metadata, that means the encrypted media file can be decryptable multiple users. But if previous users nonce is removed from the metadata, that means the ownership is transferred. So based on this approach, we introduced the final data transaction. That means that is invalidated secure data. If the encrypted media file doesn't have any nonce, that means the file cannot be decryptable. Surely it is vulnerability. If attacker maintains all the nonce and recording files hashes in their own database, it can be decryptable, but it's not logically possible to build attacker's own database because nonce is normally generated by random number generator and arbitrarily updated by user and system. So the number of case is very high, so it's very hard for attackers. So this is a conclusion. Video encryption and decentralized storing nonce is possible by introduced asset identity. Also, this asset identity provides trace and traceable features, and based on this operation, anonymous user and system can request decryptable clues from the blockchain network. And the encrypted media file can be copied without blockchain network access, but they need to access blockchain network and send a request to user to get permission through the blockchain network. That way is the video file is still secure from privacy infringement. And we tried to take advantage of media file structure to keep nonce in metadata area of media file, but it can be easily extended to in general data encryption if the encrypted data has a kind of headers to keep the nonce. And as I mentioned earlier, our proposed architecture is the main contribution of our proposed architecture is to enable information access management when each subject who creates owns user data is different. So, and another one is we introduced deletion. So we that is completion of users privacy protection mechanism. Okay, that's all about my study. Thank you.
That's so wonderful. It's a very good presentation. I think
thank you very much.
It's so amazing. Anybody with question? Val, do you have any question for Kim?
No.
Do you have any question for him? Don't unmute your device so we can hear you.
No.
Okay, I have a question for you,
okay.
Kim. My question is this: in blockchain, what I know about blockchain is that you cannot you cannot change any data, right? You cannot alter the data. So why do you think that this is so important for this your research? Why do you use blockchain? Because I think it's so dangerous if we cannot change anything in future, because blockchain said we cannot change anything. So
yeah,
I'm thinking if we maintain something and there is a need for adjustments, such as if I have a contract written and I want to add somebody to, maybe I have a child, I want to add my son, my daughter into the contract, because blockchain say I cannot alter the contract. So why do you think that blockchain is really important for this particular topic?
Yes, for the first time, we tried, my study just started to use our own database to keep the metadata and encryption information. But we finally, we found that to keep the database in our on-premise or their own database to keep the encryption information, that leads to TCP problem, as I mentioned, first stage. If we need to provide concrete evidence, we keep the encrypted information database insecure. That's not the original. That's not the solution to break the TCP problem. We want to solve. We want to provide concrete evidence and by using blockchain network, and we want to show how to handle our protection encrypted data in the public. We want to open the whole process to encrypt and maintaining encrypted videos. I hope it is answer for your question.
Yeah. You got, the answer is correct. I think it's clear to me what you are trying to do. I think we have 56 trying to your presentation is so wonderful, as I said before, and I think it's so good hearing from you. So now we have another presenter. I think it's Vaba. Are you gonna present? Because before I saw presenter 56 here.
Yes, I'm gonna present for paper ID 56.
Okay, please, can you start sharing can you start sharing? Okay, wait, I will make you the co-share first, then you can share. Now you can share. You mute your device. Your device, we cannot hear you. It's muted. Okay. Can you make it bigger? Just use the screen.
Yeah.
Yeah, make it bigger. Like you can take the whole screen.
Is it okay now?
Like, yeah, this is better.
Okay. So, good morning, everyone. I am Vaibhav from School of Computer Science, KIT University, India. And today I will be the presenter for the paper Detection of Network Intrusion and Classification of Cyber Attacks using Machine Learning Algorithm, a multi-stage classifier approach having paper ID 56. Can you see the introduction screen?
Yes, we can see everything very clear.
Okay. With growing uses of technology, intrusion detection became an emerging area of research. NITS, or basically network intrusion detection system, can be a device or can be a software which keep monitoring the network traffic for malicious or abnormal activity. The real question is why we need NITS. Traditionally, the intrusion were detected by authentication such as password and keys, firewalls, and encryption and decryption of network traffic, which are considered as the first line of defense. The first line of defense is not so flexible and not so powerful, and it can be easily bypassed by an intruder. The second line of defense can be an antivirus software or a network security software, which is somehow helpful in restricting the intruder. But the main problem with it is that they are only able to detect only those attacks whose signature are present in the database. So if a new type of attack is done, they are unable to detect. The concept of our study. We have presented our study in two phases. In first phase, we have the first phase, intrusion detection. We have performed binary classification for detecting whether there is an intrusion in the network traffic or not. In the second phase of our study, which is intrusion classification, we have when an intrusion is detected, then we try to identify which type of attack that intrusion were, which family of attack it belongs to. In our study, or basically in the research of network intrusion detection system, the main problem unavailability of the comprehensive network-based data set, which can reflect modern network scenarios along with low footprint attack environment is a major problem. Dataset like KDD Cup 99, NSL KDD, etc. also does not reflect the lower footprint attack environment, and also the many datasets have redundant and missing record, which are major problem. So for our study, we have chosen dataset UNSW NB15 dataset proposed by Mustafa, etc. all. The dataset was, it reflect, the reason we have chosen this dataset because it reflect the modern network scenarios along with lower footprint attack environment. The dataset was acquired by considering 3 virtual servers, one for malicious or abnormal activity, and the other 2 for normal network traffic. In total, the dataset represents 9 major family of network attacks. Redundant or irrelevant features in data have caused a long-term problem in the network traffic classification. Such features not only slow down the classification process, but also prevent the classifier for making accurate decisions, especially when coping with a larger data set. So for efficient use of the system, the redundant and irrelevant feature must be removed. And we have for classification phase, the classification phase is done using 4 machine learning approaches, which are K nearest neighbor KNN, artificial neural network ANN, random forest, and XGBoost. Coming to the first phase of our study, intrusion detection. In intrusion detection phase, we perform binary classification for detecting where there is an intrusion in the network traffic or not. In total, we detected and classified 93,000 non-intrusion samples and 1,64,673 intrusion samples, which includes 58,871 generic samples, 44,525 exploit samples, 24,246 fuzzers, 16,353 denial of service samples, 13,987 reconnaissance sample, 2,677 analysis, and 2,329 backdoor, 1,511 cell code, and 174 worm samples. Different models were compared based on the precision, recall, and F1 score, and the highest accuracy was achieved using XGBoost. We were hoping the ANN will perform best, but the XGBoost outperformed other algorithms. You can see this graph which shows the total non-intrusion and intrusion which have detected. Coming to the second phase of our study, intrusion classification. When network intrusion is detected in the network traffic, then we come to the second phase of our study, which is intrusion classification, to classify the detected intrusion belong to which family of attack. In this also, the XGBoost outperform other 3 major machine learning approaches, which are K nearest neighbor, artificial neural network, and random forest. When we studied this, we came to know there was a misprediction. When we analyzed the result for intrusion classification phase, we came to know that the most of the attack, which are from the denial of service or DOS class, has been classified to exploit. When the reason for this misprediction were analyzed, it has been found that there are 2 major There are two major features, which are S bytes, which correspond to source to destination transaction bytes, and feature SPKTS, which means source to destination packet count. These two features are having high correlation and are in a common range for the record pretending to be DOS and exploit class. Hence, such misprediction have taken place. So for general prediction, these two features must be handled properly. Coming to the conclusion,
Baba?
Coming to the conclusion, nowadays computer plays a very significant role in human life. The spectrum of security issues, considering the content of our data and information. Hence, working in a scenario where it is a secure cyber world has a dramatically impact on a user or an organization's privacy. First and second line of defense are not so powerful enough to provide a secure environment. So a NIRS, network intrusion detection system, is must in detecting intrusions. And for for our study, XGBoost outperformed the other machine learning models by providing the highest accuracy. This was from our side. Thank you for your time.
Wow, so wonderful. Please, it was so, your work is so good. I don't know whether Kim, do you have any question for him?
Oh no, it's a little bit tough. It's tough for me. I have to read later. I have to read the paper later.
Yeah, I thought as much. I think it's a very hard topic. Actually, because I did some work in this using machine learning in a different field, so I have idea what it's trying to say. So I have a question for you, Bob. My question is this: you know, as you said, you use artificial neural network, right?
Mm-hmm.
And you use, why didn't you use something like decision tree to show some of your work? You think it cannot be implemented here?
We have used random forest, and we came to know that XGBoost outperformed random forest. So when we studied, so random forest basically outperformed decision trees. So we thought of not including it, because random forest is just the randomized forest for a particular decision trees involving.
Okay. So far as you have shared this, where can we implement this? Where do you think that this can be implemented?
Network intrusion plays a very important role. As I mentioned, the first and second line of defense is not so flexible and powerful enough in detecting the intrusion. So network intrusion detection system plays a major role in detecting intrusion and to classify, so that the organization or a user can know which on which type of attack their system is most vulnerable.
Okay.
And it can help in providing a secure cyber environment for which have a dramatically important impact on a user or an organization privacy.
Okay, so if somebody asks you, like, just in conclusion, what is the main, where do you people think this can be relevant? This your work can be relevant. You will tell us what in just a word.
Sorry?
This research you did, which area can it be deployed? Like, you think is the most needed for this algorithm you did?
It can be utilized on a particular individual site or for an organization.
Okay, every organization needs it, right? Okay, okay. Thank you so much. I think you did a good job. And I don't know whether you and Kim knows that we have our opening ceremony today. Are you aware?
Yeah.
And I hope you will be there because it's going to be something wonderful. Our keynote, we can't wait to hear from him speak. I think he's really prepared for us. So everybody try as much as you can. Kim, are you hearing me?
Yes. Yeah.
So please, I'm just thinking of every one of us should show up for the keynote speech. And we have about 3 of them speaking today. Then tomorrow they will now conclude with keynote speech. So please try to be there. Actually, what happened is that other people has presented. We have presenter 51 did his job, and I will stop you from sharing so I can share this one.
Okay.
So because I want to show something. Before you people could share, because only both of you didn't show up, actually. Other people were there, you know. Presenter 51 shared about their work. It was so wonderful. Can you see the screen? Can you see the PowerPoint? The Smart Cyber 2020, can you see it well?
Yep.
Okay, so 51 presenter did, 56 presented. Then we didn't find a team didn't show up. Maybe probably it's still gonna show up. Then 29 didn't show up, and the U56 just did now. You were not there then. So when we couldn't find some people, we thought, you know, but presenter 4 did. He presented. So it was okay that we just have like almost 40 minutes waiting for a long time. So we thought that people are no more coming. So we cut it off. And we have other friends of theirs, of the same people, maybe the people that wrote the paper. They were all there in the first one we had. Maybe YouTube, you can actually find their paper and go through their presentation. It will help you a lot. So, and also they will see yours because yours is also broadcast in YouTube. So they can also watch it later. We will send all this to everybody to have an idea what's the other.
Yes, I just got the mail for the YouTube links. I will go through that.
Yeah. I think it's really important we do that way. So because I don't know, Sin did, are you, which presenter? Unmute your device because we cannot hear what you're saying. Unmute your device, Sin. Cindy just came up now, so I don't know whether it's the next presenter so that we don't take the time to waste while talking. Are you presenting? Please unmute your device.
No, sorry, no.
Okay, you're not presenting. You're not presenting?
No, I'm not.
Okay, I got it. Okay, she's not presenting. She's just part of what watching what is happening. So is a participant. Then so we had total now we're supposed to have like 8 presenters, but we have now 5. So 3 people didn't show up, but we don't know whether they will still show up because this presentation should end by 12:20. So now we have, this is 12, so we have 20 more minutes for any other person who is going to show up. So we'll wait a little bit. Is that okay with you people? So that if they show up, we know. We just wait for maybe just 5 minutes more, because I don't think if they didn't show up till now, I'm not sure whether they will still show up. So that what happened when we couldn't see you people, 2 of you, we went off with all the people that were there. So don't get disappointed and say that nobody was watching your presentation. No, people were there waiting, but I think we thought it's gonna be like everybody will be there. If it is your time, you just present. That was the plan before, but it's like people just wait for their own time to come up. So I know we don't really have time now, but that was what happened. So anybody who have anything to say? You can unmute your device so that we can hear you, because your devices are all muted, so we can't hear anybody. Yes.
I have a question.
Okay, please go ahead.
The presentation is open to YouTube later, or just it's for live streaming.
It's live streaming.
Just for live streaming. It's not recording for on
No,
YouTube.
no, it's recording. It's recording, of course.
Recording. Okay, and then that means I can see the other presentators' presentation later on YouTube, right?
Yeah, definitely.
Okay,
you will see everything. Yeah, you will see everybody.
Yeah,
okay. That's what I was trying to explain, that even though you miss them, you can still, because you need to see their present, just like yours. It was so wonderful, just like what you people did.
Thank you.
So it's better you also watch them to see what other people are doing.
There are lots of interesting topics. Yeah.
Yeah, everything here is so interesting. In fact, I learned a lot also myself. So, Baba, do you have anything to say? Any other contribution or anything to say?
No, thanks.
Okay. So how are you people coping with the coronavirus in your countries? Is everything getting better, like in terms of movement of people?
Yes, I think it's getting better, but getting worse again. Yeah, but it's a kind of pattern, become a pattern to protect ourselves from the coronavirus.
Yes.
We just stay at home from time to time, even for working. But I think it's important to stay the distance from people distance. Yeah.
Thank you. That's why our online was just perfect, I guess.
Yes, right.
Perfect. So nobody has any issues. So at this point, I think since the next person didn't show up till now, I will just I think I will stop. If I will just yes.
Okay,
so
then.
Please don't miss our event. Please come.
Yeah, I will join to keynote presentation.
Yes,
I'm looking forward to what they say. Yeah.
Yes, you will enjoy we met him yesterday online, so I know he's really prepared for the whole thing. So please try to be there.
Okay.
Thank you for everything. Thank you for sharing, and we are very happy to have you on. And despite all your time schedule, you were able to make it here. Thank you so much.
Thank you.
Bye.
Bye.